Okay, everybody, welcome to the April 14th edition of the Study Hall. Today's topics are a firm foundation of data sufficiency. What this means, in previous classes, we've encountered a lot more sort of resistance, if you will, from the basic format of data sufficiency. So that's the format that underlies all of the different problems. And realistically, without a firm foundation in that format, it's very difficult to perform well at data sufficiency. So the goal here is to build a firm foundation in that regard and then use that to solve some problems, and if there's time, some coordinate geometry as well. Continued from last time, we got a bunch of other good problems to look at. So the usual warnings we got to start with. Same warnings we always give, but people are still not doing this. In particular, please don't submit single problems by themselves. This is something a lot of people keep doing. Please don't do it. That's what we have the forums for. Please do not submit single problems by themselves. Because, again, the material that you're allowed to submit here for the study hall is exactly the same material that you are allowed to submit for the forums. So individual single problems, please post on the forum. That is why the forums are there, so that you can search the threads and look up explanations easily. Also, please don't be too general. Again, please don't ask for something like geometry as a whole or how to solve problems faster, which is basically the entire test. Those are not legitimate topics. Also, a couple people did this past week. Please do not submit personal issues. These study plans, my score is this and that, my goal score is X kind of thing. There's a folder in the forum in which you should discuss those. That's called the general questions folder in the forum. What you should do is give us topics that are reasonably general, intermediate generality. For example, this is not too broad and not too narrow. If you're going to submit a single problem, you need to tie it into a more general question. Otherwise, we will just ask you to put it on the forum. Also, don't forget, no problems from the official guide. Please do not submit problems from the official guide. Okay, about half of our submissions last week were from the official guide. Please do not do that. We can't use those for copyright reasons, just like on the forums. Also, please check the archives. A lot of people are submitting topics. We have taught this study hall about 30 or 35 times now. So we've been doing it for about a year and a half. So there are a lot of topics that have already been covered. And we try not to do duplicate sessions. So please check the archives before you post a topic. Smiley face icon, please, if these rules make sense. Again, it's like the first part of an airplane flight. We have to give you the rules before you take off, even if you've flown hundreds of times. All right. Let's talk about data sufficiency. Getting our feet back on the ground here. And what I mean by that is data sufficiency is a very weird format of problems. Data sufficiency is strange. I mean, for lack of a better word, it's weird. Therefore, many of the difficulties that you're going to encounter will stem from the format of the problem rather than from the problems themselves. As a result, this is what a lot of people are overlooking. I mean, it's understandable. I mean, it's easy to think that a difficulty with math problems automatically translates to a difficulty with math. But it really doesn't. I mean, most trouble that people have in data sufficiency is actually not related to the math. It's related to what is going on here, what is this weird format of questions. So as a result, what you should be able to do here is this. Before you start any data sufficiency problem, what you should do is answer, or at least make sure that you understand fully the following four things. The first thing, I'll call it number 0 because it's like a preliminary consideration, is which type of data sufficiency problem is this? Okay, that doesn't mean type as in things like geometry and things like that. That's not what we're talking about. There are two broad classes of data sufficiency problems as far as format. Does anybody know what those two types are? Two different types of data sufficiency formats. Text box if you know. Okay, Mira's got it. Drew E or Drew, I don't know if that's just Drew or if it's Drew E. What is the value? And yes, no. So find the number or yes or no. Those are the two types of questions. Please don't confuse them. It is understood that, okay, by the way, we do expect that the viewers here have a certain degree of competency here. We expect that people attending this lecture are already going to understand how these two different problem types work. I mean, we'll reiterate as we go, but it's expected that if you're watching this, then you have a basic knowledge of data sufficiency. Okay. Question number 1, what exactly is the problem asking for? So, like, what quantity? If it's a find the number problem, then what quantity? And if it's a yes, no, then it's asking whether what? Fill in the blank. This sounds like a rephrasing thing, but it's really not even that. It's just understanding what's in the question, because a lot of people have trouble because they don't spend enough time figuring out these basics. Question 2, exactly what is required for a statement to be sufficient? And then exactly what, question 3, is exactly what is required for a statement to be insufficient. Okay, note in question 2, note that if it's a yes-no question, there are going to be 2 possible answers to this. Make sure you know this. All right, if it's find the number, then it should be one value of what? But then note, the important thing to note here is that if it is a yes or no question, there will always be 2 different kinds of sufficient. And this is where a lot of people have trouble. There will always be 2 different kinds of sufficient. One that gives a yes and one that gives a no. So you need to figure out what those are. I mean, we're going to do this for the examples that we see here in this lab today, but many people make the mistake of thinking that on a yes-no question that there's only one way to get sufficient, and there's not. There are always 2. There's a yes type sufficient and there's a no type sufficient. And then on number 3, if it's a find the number question, then insufficient means 2 or more values of something. And if it's a yes-no type question, then It could be something or could be not something. This is sort of abstract right now, but when we see the problems on the following slides, we're going to make a little bit more sense of this. So the best way to learn something, we can theorize all day if we really feel like it, but the best way to learn this sort of thing is to put it into action. So what we're going to do now is dive straight into some problems. So let's take a look. Before we do, if you've been here before, this is old news, but when problems are given to the class, the deal is please do not answer the problem in the text box. Instead, what I will give you is I will give you 5 options of multiple choice. Let me show you what those look like. Below the window where you see names of attendees, you will see this. Okay, smiley face if you guys see these 5 buttons on your screen. Okay, please answer the problems using these buttons. I mean, the reason why, again, is that everybody can see the text box. So we don't really want, I mean, the GMAT is not a team effort, so we don't want people to be seeing each other's answers prematurely. So if you use the buttons, I've got it set up so that you don't see each other's answers so that all of you have the authentic experience here. All right, smiley face if you guys are ready to go and do some problems. Someone's giving a non-smiley face. Well, that's what we're here for. Adam, if you're giving me a non-smiley for some other reason, then in the text box tell me what that is. I'll try to take care of the issue. If you're just trying to be funny, then haha. Okay. Here's the first problem. I'll give you a stopwatch for, this one's kind of short, so I'll give you like 1.5 minutes. Go. Okay, our friendly stopwatch has come to an end, so please try to indicate an answer shortly. Remember that this is the GMAT, so you are not allowed to skip problems, and you are not allowed to leave them blank. So I'm looking at you, Adam, Daniela, Dan Lerman 1, and yeah, please guess something, and Drew E. Give you about 10 more seconds to produce a guess. Okay, we're going to move on. Adam, Dan Lerman, number 1. You're not answering the question. Remember that GMAT doesn't allow that as an option, so make sure that you get a little bit more decisive in the near future. But here are the class statistics. Let's talk about this problem because most of you got this incorrect, and presumably for reasons that are a lot like what we just put on this slide. In other words, you're not really spending enough time to notice. Okay, it looks like Adam and Dan Lerman picked answers. So here are your updated statistics. The updated statistics are here. Okay. Still, that's a little bit better, although the majority of you are still incorrect. By the way, the non-response is me, so that means everybody answered the problem. So there you go. Let's do these 3 questions here. Just a second while I rig something up here. Okay. Sorry for that delay. Okay, let's talk about these 3 questions. The first question, the 0th question here actually, is which kind? This is a yes-no question. Now let's talk about what exactly is the problem asking. The problem is asking, text box please, what is the problem? I mean, you might just be reiterating what is on the screen, but that's fine. It's good. It's good to reiterate the question. Remember, a yes-no question, it should start with whether, or you can say if, although it's more properly whether. Whether X and Y are both keyword positive. Okay, now here's where the juice starts flowing. What would be sufficient? Remember, there are going to be two types. The first type is a sufficient yes. Someone tell me what that would be. And remember, don't just say it would be a definite yes. I mean, that's where people have issues, is they don't take the time to flesh out what that actually means. That's the problem, as you will see. Those of you who picked A, that's the issue. Sufficient yes means X and Y are definitely both positive. What's a sufficient no? This is where the rubber really hits the road here. And if you didn't get this right, this is probably why you didn't get it right. Derek has already said it. One person has said X and Y are not both positive. That's true, but that's not a very immediately obvious statement. Like, that's one of those statements that sounds like a jumble of logic. Someone tell me what does happen if you have a definite no. Yeah, Dan's got it. At least one of X and Y must be less than or equal to 0. Notice that it's just at least one. This is a huge, huge takeaway here that you should learn. The opposite of a statement of everybody does this is at least one doesn't do this. And similarly, it's vice versa. The opposite of somebody, or at least one, is nobody does this. Or everybody does something else. Okay, this is where people run into a lot of trouble, because a lot of people are thinking that a no answer here is that both numbers are negative. And that's not true. So, are X and Y both positive? Let's examine the statements. And then first, let's do question 3. Question 3 is what would be insufficient? So someone tell me what would be insufficient. Notice that in any definition of insufficient, you have to give me at least 2 cases. So insufficient means that what can happen and also what else can happen. Text box, please. Yeah, at least one case in which both numbers are positive. That's a yes. And at least one case in which one of them is 0 or less. At least one. So Does this make sense? I mean, again, it's still not a good idea to just say yes and no, because if you do, you're not digging into the meat of the issue, which is exactly what comprises a yes and exactly what comprises a no. It's harder than you think to sort that out exactly. It's very easy to get confused. Are we on the same page? Smiley face if we're on the same page here. Non-smiley face if we're not. Okay, I see a sea of smiley faces. That's good. So now let's talk about the statements. Statement 1, let's import some of these things onto the next page. Let's not. Let's try to work with the space that we have here. Let me bump some of this stuff upward a little bit. Let me kill that and move everything else up a little bit. There we go. Okay, statement 1 in this case says that xy is negative. Somebody tell me what that means. Yeah, xy is negative. This means that they have opposite signs. One of them is positive and the other one is negative. So that's sufficient because that proves that at least one of them is not positive. So sufficient. But now here's where a lot of you got tripped up. Statement 2, x plus y is negative. There's 3 ways that you can do this. X and y could be both negative. They could be one positive and one negative, x positive and y negative, or they could be x negative and y positive. The way these latter 2 cases would work is if there are 2 negatives, then it's obvious that this will happen. But this can also happen with one positive and one negative as long as the negative number is bigger, because then when you add them together, the negative wins, basically. But the way this can't happen is with x and y being the same, both positive. So this is still sufficient, because this still satisfies condition no here. Like in all of these cases, at least one of these numbers is 0 or less. I guess you also have to include the cases that include 0. So you could also have a negative and 0, and you could also have 0 and negative. So that's also sufficient. I mean, the other way to look at it is just that it's impossible for both numbers to be positive in this case, and that's good enough. Again, you don't need them both to be negative. You don't need them both to be anything, but it's either both positive or at least one not positive. Smiley face if this makes sense, so the answer should be D like dog. Smiley face if we are good here. Again, these 3 questions, make sure you take this away from this study hall and start doing it. You will find that data sufficiency becomes a lot easier if you take a few seconds at the start of the problem to hash this stuff out. In the case of a problem like this, even if it takes you a minute to figure this out, look how fast the problem is once you actually figure this out. So it's worth the time. Next problem is very similar. Let's make sure that this has sunk in. Same deal, please use the buttons. Because we've already seen it, I'll give you about 1 minute because we already had the setup. Go for it. Okay, that's only a minute, but because we already have done the basic setup of this problem, let's try to answer it relatively soon, please. That's everyone. Let's try to get answers from AHR, Adam, and Dan Lerman 1. Okay. AHR, you just press it once. We're good. Okay, everybody's got it. Let's look. Here are the statistics from the class. Again, please don't press your answer buttons twice. If you do, what it'll do is cancel out your answer. If you press the same answer you've already pressed, it will just delete the answer. That's how you actually take away. All right. Here's the result. The class did a lot better at this one, but still we had people picking the others, so let's make sure we discuss. Remember that a yes on this question means both positive, and a no means at least one is not positive. Also remember that your goal here should be to try to prove insufficient when you consider cases. In other words, try to get both of these things, and if you can't, then say, okay, I guess it's sufficient. So statement 1, if xy is positive, what does this mean? Text box, please. Yeah, they're either both positive or they're both negative. So both positive is a yes. It's important to split this into the two cases. Like if you're saying same sign, that's nice, but make sure you actually say both pos or both neg, because you need to consider those things separately. So this is a yes to the question. This is a no to the question, so therefore you have proved it insufficient. Statement 2, if x plus y is greater than 0, what does that mean? Yeah, it means one or both of them are positive. So again, we should try to prove insufficient. If only one is positive, then this is a no. But if both are positive, then this is a yes. So that's insufficient. And then if we put them together, yeah, Dinesh, you're right when but that's almost impossible to read. I mean, like I have to look at that about 8 times to make sense of it. So it's better to use words like positive and negative, like the other posters are doing. Okay. Together, if you put them together, what does it mean? Next box, please. Again, please write it in words. If you put them together. Yeah, because from statement 1, they both have to go the same way, but from statement 2, I know that one of them is positive, so they both have to be. So that's a yes. Okay, I think we get it. Some food for thought to take home with you. So the final answer to this thing is C. Again, the answer is not so much the point as the process is the point. A thought to take home with you is if you change this question to are x and y both negative, then the answer becomes B. So see if you can figure that out at home. Okay. Let's look at something new. Let's see. Try your hand at this one. Again, it's not supposed to be super duper complicated, so I'll give you about 1:45. Okay, time's up. That's about 2 minutes, including discussion. So please, I'm looking at Pernendu and Dinesh and Danielle. It looks like she's away. So if you are Dinesh, please indicate an answer. Let's go. Okay. AHR, I see that you have some text written in your box. If that's a question, keep typing. Otherwise, please erase. Okay. Yeah, that's the point of today's session. If you didn't understand the problem, that's actually why we're doing these, because a lot of people don't understand these. So let's take a look. The majority answer here is correct, but that's still only 50% of the people here. So let's make sure we know what's going on. What type of question is this? This is a number question. This is a find the number. Okay, exactly, yeah, find the value. Exactly what do they want? What do they want? So you guys can give me an exact, and don't just say the value. Like, actually tell me in very precise terms, what do they want? They want the maximum of x and y. Yeah, they want whichever one is bigger. So they want a number for the bigger value among x, between x and y. Let's see if any of you know where I'm going with this. What do they not want? I know that's kind of I mean, there's a lot of things they don't want. I mean, for example, they don't want the altitude of, of Montevideo, Uruguay. But see if anybody knows where we're going with this. Like, what should you not be worried about in this problem? Yeah, Chandra, that's perfect. You should not be worried about whether that value happens to be x or y. You should just worry about what is the number. I mean, remember that at the end of the day, a problem that is find the number is only asking you to find a number. Like, it cannot simultaneously ask you to find a number and to tell you which letter that number is. So they don't want, you do not care whether that number happens to be x or y. So what would be sufficient to this problem? Text box, please. Yeah, that's a pretty good summary. A couple of you are typing, so I'll see what you finished typing here. What would be sufficient would be a single number for the maximum value. Again, all that matters is a single number. We don't care whether this number is assigned to x or y. What would be insufficient? Text box, please. Yeah, you'd have to have two or more possible maximums. Again, we don't care whether it's x or it's y. We just care what the number is, and you would have to have two different maximum numbers. Okay, let's analyze the problem. Statement 1, you could have like 1 and 7. That would mean your max is 7. You could also have like 2 and 6. So your max would be 6. So this is insufficient. Any questions? Type them in the text box, please. Statement 2, you could also have a whole bunch. A couple of you said this was sufficient, but you can have a whole bunch of different products too. You can have 3 and 5. Max is 5. You can have 1 and 15. The max is 15. You can also have negatives. So you could even have irrational numbers. I mean, you could have square root of 15 and square root of 15. So, by the way, if you do have 2 of the same number, then the greater of them is just whatever that number is. That's actually not considered an issue. So you could even have square root of 15 as your maximum. I mean, you could. I mean, the reason I'm showing you this last example is to emphasize the fact that these things don't have to be integers. So there's a million different cases of this. So this is also insufficient. Smiley face if these 2 cases make sense. Okay, to save some time, I'm not going to show the routine algebra, but I'm just going to describe what it would be. Together, if you do routine algebra, the way you do it is you solve like y equals 8 minus x, and then you substitute into the other equation. If you do that, then what you wind up with is either x equals 3 and y equals 5, or you get y equals 3 and x equals 5. So either way, the max of these 2 values is 5, so that's sufficient. Because again, we don't know whether that max happens to be x or y, but we don't care. It's 5 in both cases, and that's a hard number, so we're happy. So this is C. Any questions about this problem? I see one person typing in the text box. What does that equation have to do with this problem? Okay, I know that's interesting. I'm not really seeing what that has to do with the problem that we're looking at here, but yeah, all right. Questions? Okay, let's see. Someone is typing something, so let's wait and see what that is. If it's an alternative algebra wizard way of doing this, then let's table that, because the most routine, most straightforward way to do this is to substitute. So yeah, I mean that works, although that's like 1,000 times as complicated as just doing this. So and also you have to contend with, still, even after you do all that, you still wind up with a system to solve, because you still have to solve x plus y is 8 and x minus y is -2. So not efficient. I mean, it's cool. It's a nice little bit of algebra wizardry, but it'll take about 6 times as long as doing this. Okay, next problem. Let's look at it. Go. Two minutes. Let's see. People are having a hard time here, so I'll give you an extra 20 seconds or so. Go for it. Okay, what doesn't surprise me is that most of the people who answered this problem early are incorrect. In fact, the first 5 answers I saw to this problem were all wrong. So let's see. If you're AHR or Pernendu 1, please answer the problem. Again, the GMAT doesn't allow you not to answer, so please guess if you have to. Okay, here's the statistics. So we are all over the place on this one. Again, data sufficiency, a couple of you answered the problem in like 45 seconds, and you were wrong. Not a surprise. Again, data sufficiency is not usual. There's usually some kind of trick or some kind of thing that you have to take a little bit more time to contemplate. Problem solving, it's possible that you can knock out some of these things in 45, 30, 20 seconds. But if you think you can solve a data sufficiency that quickly, then it might be something that you're missing. So, okay, these things involve comparisons of powers. Can anybody tell me what kinds of numbers we should think about when we do that? Fractions meaning numbers between what and what? Yeah, we should think about numbers between 0 and 1 versus other numbers, because those numbers' powers are backwards. And then there's another type of number that we should also think about, especially because there are even powers in the mix. But what other type of number should we think about? Besides integers and fractions and zeros and stuff, there's a very super hugely important class of numbers that nobody has mentioned yet. Yeah, we need to think about negatives. So we should also think about negatives, because those are backwards too. We don't need to think about -1, 0, and 1, because these things are mostly equal at those values. But let's think about the intervals of numbers between those things. So we have, here's a number line. Here's the 4 regions of the number line that we're most concerned with here. So let's think about these 4 areas of the number line. Okay, statement 1 is true. Statement 1 is true in this region here, because, like, if, for example, let me divide these regions up with a line here. For example, the cube root of -8 is -2. So -8 is indeed less than -2. So this works. Not here. For example, -1/8 is not less than -1/2. So this would be false. It's true again here. Students, I'm not sure what those pluses and minuses are supposed to be talking about. But okay, here this is true again because, for example, 1/8 is less than 1/2. And then it's not true here. Because 8, for example, is not less than 2. Now, let's stop for a second. We're not doing our due diligence here. What's the question? We didn't do our 3 questions first. So let's move this downward a little bit. Where is, what would be sufficient here? This is a yes-no question. So someone tell me what sufficient would be. Remember, there's going to be 2 kinds. That is not necessarily true. AHR, no. You're trying to do too many steps at once. Yeah, I'm not even looking for something that advanced. I mean, that is what it winds up being. But yeah, either x must be more than 1 over x, or x can't be more than 1 over x. That's what sufficient means. If you're trying to do all of this crazy rephrasing ahead of time, it's too many steps at once, and you're going to get confused. I mean, right now we're just looking for either must be or can be. And then insufficient means someone's giving me a non-smiley face. So please explain why in the text box, and I'll try to take care of you in the flow here. Insufficient means you'll have a case where x is greater than 1 over x, and another case where x is not. So, yeah, no, it is confusing, but it's a lot more confusing if you don't take the time to hash this out ahead of time. Yeah, no, it's definitely confusing. That's actually the point. That's why it's in today's study hall, because it's confusing. So, all right. So notice the statement, the question prompt. Let's address that. Is x greater than 1 over x in this region? No, it's not. For example, -9 is not greater than -1/9. So the same thing will be true in that region. Is x greater than 1 over x here? Yes. For example, -1/2 really is greater than -2. Here it's not. For example, 1/2 is not greater than 2. Here it's yes. For instance, 9 is greater than 1 over 9. So notice that these two regions produce no's to the question, whereas these two regions produce yeses to the question. So statement 1 actually gives you a sufficient outcome here, because you have, these are the only places where statement 1 happens. So, and those both give you no's to the question. These are the regions that satisfy statement 1, and those are both no. So statement 1 is sufficient. Questions about that? See one person typing a question. Okay. It also seems like, Chandra, I see you typing. I also see that your board seems to be a little bit behind in updating images. So maybe that's the question. But it looks like it's a problem on your end. Okay, statement 2, let's look at that. Statement 2, x is less than x squared. That's definitely true here and also here, because x squared is positive. So, same thing here. So that's a non-issue in those regions. It's not true here, but it's true here. Because this is the, for example, 1/2 is not less than 1/4. So here, this is your normal standard numbers. So But this is an insufficient statement because these are cases where the answer to the question is no, and these are cases where the answer to the question is yes. So statement 2 is not sufficient, and the overall answer to this thing is A. So again, the difficulty here, I mean, this problem is genuinely sort of hard all around, because like these things are not super obvious either. Like this is a lot harder than the last problem was. But at the same time, a big part of the confusion here is that people don't take the time to figure out the question prompt. Like people will spend a lot of time on the answers, but they won't spend as much time on the question prompt. I mean, you need to figure these things out about the question prompt here. So, any questions? If that's the rephrase of that would be this. The regions you want, x is greater than 1 over x turns out to mean either between -1 and 0 or greater than 1. So the rephrase is also sort of awkward. I actually made this problem. So this came from the twisted, weird book of my head. So, yeah. All right. Anyway, I mean, problems like this are not hard to make. I mean, like you can. I mean, as long as you know that you want to make a problem about, because these are all standard things. I mean, you guys could make this problem too. Because I mean, this is a reciprocal, this is a root, this is a square. I mean, I just wanted to test this. But there's nothing terribly creative about this problem. I mean, it's just, okay, let me throw a bunch of comparisons into a question and see what falls out. So you guys can make your own variations on this problem and see what happens. I mean, you can literally just take any powers of x and make a question by just putting them into a problem. The only thing you have to make sure is that you don't get statements that contradict each other. But other than that, you can literally scramble any roots and powers and make your own data sufficiency question and see what happens. Derek, I mean, I'm not going to lecture you guys on how to organize problems. I generally find that organizational devices as a whole are extremely helpful. On the other hand, I've also worked with enough students to know that what works for one student organizationally is tedious for another student. For example, if you are very naturally organized in your thought processes, then you don't need to do as much of this. Like, part of the reason that I make so many charts and tables when I do problems is because the inside of my brain is a tangled, horrible mess of chaos. And if I didn't make charts, then I would never remember anything. But the other reason is that charts make it easier to teach the problem. But what I'm saying is this. Like, if you tend to be a little bit less organized personally and more of your attention deficit type, like me, then you need to make a chart every single time you can make a chart. If you are a little bit more organized naturally in your thought processes, you probably don't have to make quite as many charts, but with something with this many cases, I would still go ahead and make one. I mean, it can't hurt, although, again, for certain types of people, it might be tedious to the point of being distracting. So it depends on you. It's not a like hard advice kind of situation. It's what would be good advice for one person would be bad for another. Okay, I don't see any more questions, so let's go on to another one. There we go. I also made this right before the class started, actually. So this is also not from any other source. This problem will probably eventually appear in our CAT tests. Yeah, the recordings are always available later. There are no exceptions to that. Like, we keep them all on the website pretty much forever. So, okay, go for it. Public service announcement, there are 3 of you who answered the question in the first 30 seconds, and all 3 of you are incorrect. Back to your regularly scheduled programming. Remember, the advice we give about data sufficiency, it's not a joke. If you think you have some super retardedly easy solution to something, it's not going to be right. Keep working. Okay, take another 20 seconds or so if you need it. Maybe 20 or 30, because I know I interrupted you guys. Okay, KL and Chandra. We need answers from you. Chandra got it. KL, all right, we're good. Here's the class response. Okay, not bad. Again, I just made this problem, so I would just be guessing about how hard it is, but I'm sure that it's not, like, super easy. Okay. Let's look. This problem, if you try to attack this using y equals mx plus b, I can't imagine how you would really do that. That's going to be hard. But let's look at, if you picked A or B, and one of you early answer people had A until you changed it. These are just statements about, or D for that matter, these are just statements about intercepts. So you should be able to dismiss the first couple, the individual statements by thinking visually. So let's think visually, because the algebra here is going to be a freaking nightmare. Remember what we said about coordinate geometry last couple of weeks? There's visual and algebraic approaches. Let's think visually. What does statement 1 mean visually? Yeah, that's pretty good. They're equidistant. They're located at equal distances on opposite sides of the origin. So that just means that you have one y-intercept that's up here, and you have one that's down here at the same distance away. That looks closer right now, so let's move it. Okay, like some situation like this. That's definitely not going to tell you whether our lines are parallel or not, because you can quite literally draw any lines that go through these points. So, for example, I could very well draw two lines that are parallel, like that, or I could very much draw two lines that are not parallel. So I could have this line, these would be parallel, or like these here. Why does it hate me? Okay. Like, or you could draw it so that it's non-parallel. Like this would be non-parallel. So that's not going to be sufficient. Any questions, go ahead and type them in the text box. So statement 1 is not sufficient. Statement 2 just means that on the x-axis this doesn't happen. So statement 2 is the x-intercepts are located anywhere other than non-zero, other than equidistant from the origin. So in other words, that I mean, this is definitely not going to tell you whether it's parallel, because you have basically two x-intercepts that are almost anywhere, except like here, equidistant, and they can have any slopes in the world. So that's not going to be sufficient. If you thought a number of you thought statement 2 was sufficient between B and D, that's like 3 or 4 of you. If you did, it probably means you didn't read the question correctly or something, because there's nowhere near enough information here right now to conclude parallel. So again, our 3 questions, the first, I guess it's 4 questions. The type of the question is yes, no. The question is, are they parallel? So sufficient would either mean must be parallel or cannot be parallel. And insufficient would be could be parallel but could not be, could be non-parallel. Okay, I don't have room for the word non-parallel, so there you go. What about together? Again, algebra, this is going to be a nightmare. Maybe not, though. Actually, I mean, I'll try algebra on the next slide if there's time. But imagine what would parallel lines look like if I draw parallel lines through the intercepts from number 1. Does anybody know what they're going to do? Let's try. Here's one set of parallel lines. You can kind of see what's going to happen. I mean, we have there's a symmetry here, where if these are parallel, this distance is going to have to equal that distance. And with any situation that you draw with parallel lines, it's going to work that way. So what's fascinating here is that just making that sum non-zero, like if you do this, you still have the same situation going on, where this x-intercept and this x-intercept are going to have to be opposites, direct opposites. No matter what you do with those lines, this will absolutely happen. So even if you have them sloping the other way, like that, nothing will change. You still have the same situation with the x-intercepts. You still have this and this. They still have to be opposites. So parallel can only work if the x-intercepts are also opposites. So that's prohibited. So statement 2 prohibits that. So statement 2 means definitely not parallel. So statement 2 is sufficient, and so the answer to the problem is C. Questions? I think you can actually do this with algebra too. I just made this problem, so like I'm actually exploring this with you guys for the first time. But let's try. Algebra for statement 1. In other words, I have 2 lines. I mean, let's see what happens if I have 2 parallel lines. I mean, if there's no reason to use m sub 1 and m sub 2 if they're the same number. Just call them m. I mean, you don't want to introduce unnecessary variables. So 2 parallel lines with opposite y-intercepts. So just write these as y equals mx plus b, and then write the other one as mx plus negative b, because that's the opposite intercept. Let's find the x-intercepts. Okay, someone is doing algebra that Sudanshu, I think you are a lot better at algebra than me. So I don't know what you're doing there, but with that absolute value and fraction type thing. But okay, I guess you're better than I am in algebra. So if it works, it works. I mean, that method, what you're doing might be valid. I don't know what you're doing. Maybe you can explain it with words. Okay, let's just find the x-intercepts of these. to find an x-intercept, what you do is you just set y to 0. So 0 is mx and solve for x. So this would mean that 0 is mx plus b. That means that x winds up being negative b divided by m. Here, this means that 0 is mx minus b. So that means that x winds up being positive b over m. So yeah, same thing. So this is the same thing we found out graphically on the other page. If we have opposite y-intercepts and the lines are parallel, then the x-intercepts have to be opposite too. So I would say that if you're a more visually inclined person, that this proof is easier. Just look at a bunch of cases until you see the symmetry. But if you're more algebra inclined, then you can go at it from this angle instead. So, but either way, the point is that coming back to our questions here, we just proved that our lines cannot be parallel. So that means the answer to this is, I guess we have a C habit today. This one's also C. All right. Okay, again, I made this problem. We don't have any statistics on it or anything like that. I would imagine it's not super easy, but I made it about 5 minutes before the study hall started. So it might eventually make it into our cats because I think it's cool. I think it's a nice, sexy problem. Any questions? Otherwise, we'll try to knock out 1 or 2 more of these before we have to break. Any questions, please indicate them in the text box. Okay, let's try this one, because everybody loves this one so much. Okay, this one, starting now, the problems are from GMAT Prep. So the ones before are just problems that I made because I was in a panic, didn't have enough problems, and I had 10 minutes. But now we have remaining problems from GMAT Prep. Okay, so if you've seen GMAT Prep, you might have seen these before, but we'll do these. Go. Okay, let's try to knock this one out in the next 15 or 20 seconds, guys. It's about 2.5 minutes already. Okay, waiting for Adam and Sammy, and that is it, other than people who are away. Now we're waiting for Adam. We're still waiting for Adam. Remember, the GMAT makes you answer the questions, so you can't just not answer. We're going to move on here, but remember that developing the skill of responding even with guesses and letting go and, you know, getting up and moving is an important skill here. All right, here's the class responses. Pretty good. Let's take a look. What's the problem is asking for 2 points here. So it's a find the stuff question. It's a find the values. Actually, it's plural this time. The question is, it's asking what are the 2 points? What doesn't matter here? Anybody know? Text box. What doesn't make any difference here? Yeah, which one is right? Which one is A and which one is B? So sufficient is you can find the 2 points. Insufficient means that you could have 2 or more different sets of 2 points. Not just switching A and B. Okay, I'm going to run through this sort of quickly so that we might have time to do another problem. The x-intercepts are where y is 0. No, not 9, 0. Okay. But here you have factors. So this is where x plus a or x plus b is 0. In other words, negative a or negative b. So the question is, what are negative a and negative b? But I mean, we don't care about the negative signs, because if we have those, then we also have a and b. So the real question is, what are a and b? And again, it doesn't matter which is which. That's the equal observation here, is that it doesn't make any difference which is which. Okay. Statement 1 by itself is definitely insufficient because there are lots and lots and lots of pairs of numbers that add to negative 1. Statement 2 is also insufficient because this doesn't really, I mean, what you can do is you can plug in 0 and negative 6, and you get negative 6 equals 0 plus a, 0 plus b. That means that negative 6 is ab. That's insufficient, but at least it's useful information. It's insufficient because there are lots and lots of pairs of numbers whose product is negative 6. But together, it's actually, again, the same sort of situation that we had here. So again, I'm going to skip the algebra. It's the same situation that we had in this problem right here, where once you have a sum and a product, you can just substitute. So you can do the same thing here. You have a plus b equals negative 1, and ab equals negative 6. So solve for a equals, solve for either one, doesn't matter, negative 1 minus a. Substitute and solve. What you will find if you do that, again, I don't want to show the steps of the algebra, but what you will find if you do that is either a is negative 3 and b equals 2, or a equals 2 and b equals negative 3. So these are the same set of 2 numbers, so this is sufficient. Again, we don't care which one is called A and which one is called B because it's irrelevant. Like, we just need to find the 2 points. Again, what's important is to sort this out ahead of time so that you have a crystal clear idea of what it is that you are trying to do. That way you don't have to take this and wrangle around with it and worry about this stuff at the end. Questions? If not, we'll knock out one more problem. Okay, no questions. Let's do one more before we have to break. Give it a shot. Go for it. Okay, let's try to hit it in the next 20 seconds or so, please. Last problem of the day. We are waiting for KL, Neeraj, and Adam. Adam and Neeraj, if you guys are here, please indicate an answer. Okay, we're going to move on. Again, I know I'm being redundant here, but remember the GMAT does not allow you to abstain from problems. So even if you don't know what's going on, you have to pick something and then get moving. Here are the class statistics. Okay, this one is very visual, but first what we should do, I mean, a number of you picked A or D, which means you aren't processing this problem correctly, because if you take the time to do our questions here, then it should be clear that statement 1 is not sufficient. But let's look. The question is asking, you have a circle P with radius is 4. And right now, X and Y are random points. This is an important observation to make. I mean, in the problem statement, X and Y are completely random points in the plane. So that's important to dismissing statement 1 very quickly. But the question is, it's a yes-no question. In or out of the area. So outside or inside. Someone tell me what sufficient means here. Well, y is not a number, so you can't say, like, is y greater than 4, because y is not a number in the first place. So what would be sufficient? You guys are being very silent right now. Sufficient to this problem would mean either, remember there are two kinds of sufficient here, either what or what. Yeah, I mean, let's not even go that far. Let's just say either definitely inside the circle or definitely outside the circle. I mean, again, I think the fact that there is a silence on a problem like this is symptomatic of what's happening here. Namely, I think that you guys are all trying to think way too hard about rephrasing the question at the expense of thinking about super basics. Because, I mean, some of you are giving me correct statements about distances and stuff, but honestly, if the question says, does it lie outside the circle, you should all be able to produce these two in like 5 seconds. If you can't, then that means you don't yet have a sufficient understanding of data sufficiency. Yeah, in the circle, I mean, including, yeah, in the circle includes on the circumference. So let me add that, or on. Okay. Insufficient would be, thank you, insufficient would be one and the other. So insufficient would be one case. You have possible cases outside and inside. I mean, again, make sure this is understood. Okay. So if you know this, then statement 1 is immediately insufficient because y is still a random point. I mean, there's no information here about y. So if you take the time to figure this stuff out ahead of time, because like a number of you picked either A or D, which means you actually thought this was sufficient. But the y is not even discussed here. So we're talking about point y, which could still be anywhere. So hopefully these were just random guesses, but even if they were, you should have been able to knock these facts out and then eliminate this. Statement 2, also immediately insufficient because there's no relationship to the circle. I mean, no relation. Because the circle is only a function of point P. There's no relation to point P here, and therefore no relation to the circle. So if you pick D especially, that's trouble, because these are two statements that are both pretty immediately insufficient. So if you pick D, what that means is just that you didn't figure out this stuff ahead of time, and that you were just kind of wandering through this problem without a lot of direction. Let's put them together. Let's do it visually. Circle P has radius 4. So here's the circle. P is here in the center of the circle. That's P. Okay, then you've got X is 4.5 units away from P. That means that X is somewhere on a circle that is a little bit bigger than circle P. Like X is somewhere on a circle that looks kind of like that, where the radius is 4.5 instead of 4. But what you can do is just pick an X that is somewhere on that circle and use it as a general case. Because any point on that circle is pretty much equivalent, so then we can get rid of the circle. So X is a distance of 4.5 away. Now Y has to be 9 units away from X. And remember what we're trying to do here. We're trying to get a case of inside the circle and a case of outside the circle. So Y is 9 units from X, and we're trying for inside the circle or on, and outside the circle. If we can get both of these, then it's insufficient, but if we can't, then it's sufficient. So it's outside the circle is very easy to get. I mean, if you take Y anywhere that's like over here in the wrong direction, then you can get that. But let's try to get inside the circle. The problem is that this distance, this orange distance, is only how long? Yeah, the orange distance is only 8.5. Because, you know, that's the sum of the diameter plus that extra 1/2. So you're not, this isn't going to work. Like the circle of radius 9 is going to be, it's going to be too big. It's going to look something like that. Like Y can be on there, but you can't get inside that circle. So Y must be outside the circle. So this is insufficient. Sorry, it's sufficient because it's a definite no. So yet again, we're looking at C. You can also do this using distances and what's called the triangle inequality. I'll give you the skeleton of that sort of solution. What you would do is you would, I'll let you play with this at home, but here's a skeleton of, if you like algebraic geometry, here's another way to do this. Again, we're already 10 minutes over, so there's no time to take questions on this alternate method, but I'll just present it to you and you can play with it at home. What you can do is rephrase is the distance between P and Y less than 4? And a couple of you said that earlier, so that's good. Statement 1, Px equals 4.5, and statement 2 is Pxy is 9. The secret here, the trick here is what's called the triangle inequality, which states that the distance between the 2 points, xy, has to be, actually it's the third side inequality. It states that if you have two sides of a triangle, then the difference of those two sides and the sum of those two sides are the boundaries on the third side. So this is also known as the third side inequality sometimes. If you do that, if you know this fact, then in this case we have 9 minus 4.5. The third side of the triangle is Py, and then 9 plus 4.5. So that's sufficient, because none of these numbers are less than 4. So you can play around with that solution at home. But even if you don't have this background in the triangle inequality and stuff, you can still come up with something like this by just kind of thinking about how it looks, which is the point. I mean, again, you will not see problems on this test that require you to know stuff like the third side inequality. If you do, it can't hurt you, but there will be some other way that is more ground level, like this. Because they really don't want people who are more advanced at math to have an advantage here. What they want is for people who are more creative and more lateral thinkers to have an advantage. So there it is. Okay, we are done. In fact, we are super done. It's past the end of the period by some time now. So let's break. If you have any quick administrative questions, I'll take those really quickly. Strictly administrative questions, again, please do not submit topics right now, because there's no mechanism for that at the moment. You guys know where to do that. Otherwise, it's been fun. The recording will be posted shortly, as usual. I'll take a couple questions if you guys have them, administrative questions and such like. Otherwise, have a wonderful evening and keep it up. Good night and good luck.